Okay, sections 8.6 and 8.7 are on parametric equations. Now parametric equations, this is something very different. These are two functions, x of t and y of t, both based on the same variable, and they're combined to make one graph. Also, parametric equations are graphed many times on an interval, and then parametric equations are used when trying to separate different components of a model. So I'd say one of the most common is for projectile motion in physics, where you're trying to separate horizontal motion from vertical motion, and then base everything on time. So how far forward or to the right did the projectile move versus how far up did it go, and then base everything on time. Because parametric equations are usually based on time, the variable used is usually t. And then parametric equations can be recombined into an equivalent rectangular equation, very similar to how our polar equations had equivalent rectangular equations. So do our new parametric equations. So for question 1, they want us to graph the parametric equation by plotting points, then graph the equations by using the calculator, then find the rectangular or Cartesian equation for each. So I have two functions. I have my x function and I have my y function, and they're both based on t. So if I make a table where I have my t values and I'm plugging them into both equations. So if you plug 0 into the x equation, 0 minus 3 is negative 3. If you plug in 1 into the x equation, 1 minus 3 is negative 2. And then if you plug in 2, 2 minus 3 is negative 1. Okay, so now I want to plug in these same values, 0, 1, and 2, into the y equation. So if you plug 0 in for here, that's going to give you 4. If you plug in 1 here, that's going to give you 6. And if you plug in 2, that's going to get you 8. So I've plugged in these values for t into both equations, and now I have both x and y values. So now I'm just going to look at the x and y values and plot those. So I'm going to make a grid . Okay, so one more thing I forgot to mention is what this t is between 0 and 1 means. Like I talked about, parametric equations are graphed many times on an interval. So they're not considering it for all values. They're just considering it between 0 and 2. And that's why we're only plugging in these values between 0 and 2. So our graph is only going to be defined from 0 to 2. We're not looking at 3 and we're not looking at negative 1. Okay, so when I'm graphing it, I'm only really looking at the x and y coordinates. So negative 3, 4 would be negative 3, and then up here at 4. Negative 2, 6, just like any other rectangular coordinate. Negative 2 to the left 2, and then up 6. And then negative 1, 8, that's going to be left 1 and up 8. So this would be my graph. It's just kind of a line. Part B, I want to use the calculator. So I need to be in the right mode. So if you go to mode, let's see, we just finished polar mode, so I'm changing it over to parametric mode, which is PAR on my calculator. And then if you go to your y equals, you'll see that you have x of t, y of t, you'll see like 1 and 1 and 2 and 2. That's just really identifying the number of the equation. So I want my x1t, meaning my first x equation, to be t minus 3. And you'll notice that your variable key now, instead of typing x or theta, types t. And then my y1 of t to be equal to 2t plus 4. So then if you go to window, we want the t min to be 0 and the t max to be 2. And we really get that from there. And the t step, I'm going to put that at 0.1. And let's make the x min -8, x max 8, y min -8, and y max 8. So x min -8, x max 8, y min -8, y max 8. The x and y mins and maxes, these are a little bit subjective, but the t min and t max, that really has to be 0 to 2 because we're only defining it on that interval. So if you graph it, you should see a similar graph to what we graphed by hand. Now, you should put whether or not it's a closed dot, an open dot, or an arrow. So because these are less than or equal to's, I do want to put technically closed dots there and there to say that it's really ending there. Okay, and then for part C, they want us to find the rectangular Cartesian equation for each. So I'm running out of room. I'm going to erase my nice graph here. So C, this technique for solving these, or I should say for converting it to an equivalent rectangular form, is very much like the solving systems of equations by the substitution method. So I have x is equal to t minus 3 from here, and I want to isolate for t and plug it into the other one. So I'm going to isolate for t. So t is equal to x plus 3 if you move 3 to the other side. And now I want to substitute in the other equation. So I'm going to write this equation. Y is equal to 2, but then instead of t I'm going to put x plus 3 plus 4. And y is going to be equal to 2x plus 6 plus 4, or y is equal to 2x plus 10. So 2x plus 10, that's going to be our answer. And it's the equivalent form of this. Now it doesn't have the parameters, meaning it's not just graphed from 0 to 2. But if you were to graph it on your calculator, you would see that it's basically this line here. So it's equivalent to it, it just doesn't have those boundaries or those parameters.